Right, so question 10 of 11. We're getting there. If you read through the question, you're asked to sketch the velocity time graph for Rory's run using the model. So pause it, look at the question. Let's draw the velocity time graph. This is time, this is our velocity, and it says that, or sketch, he runs at a distance of 45 meters. So I know the total area under this is going to be 45 meters in 12.5 seconds. 12.5 seconds. Starts at rest, so it's down here. A speed of 4 meters per second. So that's 4, and then he constantly runs there. So there's a particular point at which this happens. And it says, so there's a sketch of the model. That's sufficient so far. And calculate T, calculate that. Right, I know that the total area here equals 45 meters. So I just got to work out how I work out the area of this trapezium. Now remember, the trapezium is the average length
I didn't get
times...
that. Could you try again?
Go away.
Okay.
So it's going to be a half times 4 times now. It's going to do 12.5. So that plus that distance there, which is 12.5 minus the plus the t. No, it's minus the t. I want to minus that t bit there. So hopefully you can see how this all works then. And we know that equals 45 because the area of trapezium. So that's 2 times this. So I get 25 minus t times by 2 equals 45. So divide by 2, 22 and a half. So t is 2.5. If you did that, obviously use a calculator. That's how you do that. Then it says find an expression for Rory's displacement at time t between 0 and capital T. So I've got to find an expression for displacement. Right, so, well, firstly, I need to know what my formula I'm going to use. I've got that is u is 0, so I can use s equals ut plus a half at squared, because I know the initial velocity is 0. So in order to do that, I need to find the acceleration. And I know the acceleration because they say it's 4 meters per second, but over just 2.5 seconds. The acceleration is the velocity divided by time, isn't it? So I know the velocity was 4 meters per second divided by the time of 2.5. So the acceleration is 1.6 meters per second squared. And I can then put it into here and say that s equals a half times 1.6 times t squared, and I can then work that out as being 0.8 t squared. Then it says here, use this model to find the time taken for Rory to run the first 4 meters. Right, I think I need to clean this all up here, but I think maybe I can squeeze it in here. Okay, so I know that it's 0.8 t squared equals 4. And so therefore t equals the square root of 4 over 0.8, which equals 2.24 seconds. Okay, so now I need to get to the next question, but I need to wipe all this down because it's another part to it. Part V, it says Rory proposed a refined model. Okay, so it's a quadratic function of t. So, and it goes through 0, 0, and find the maximum point at S4. So we were just asked to sketch this, and it starts at 0, so it's quadratic, so it's like that, and then straight. So that would be there, and it says at S here, and that's our 4 there. So that's what the graph would look like in terms of time. And then it says, state with a reason whether S is greater than T or less than T. Okay, well, we know that the total area under here is 45 meters, don't we? We know that. That's a statement of fact. So let's just consider the 3 different things. If it is the same as, so say T was there, then you'd get that. And that doesn't work because that area is bigger. So that doesn't work. If S equals T, it doesn't work. Okay, what about, I think you can see this isn't going to work. What about if T is, say, here? Clearly that doesn't work. Clearly that doesn't work. So the only time it will work is if T, and it's hard to actually understand this question, isn't it? I think that's a lot of people will struggle with this one. So if T was somewhere down here, then you'd get something like this. And what you find here is you'd get an area here that would balance out with that area there. So it only works where S is greater than T. How would you explain this? Maybe using a graph like this would be a good way of doing it, but it is quite complex, isn't it?